And going slightly deeper into the drivers, there are a few issues. I would try to put them under four major categories. One is over exploitation of resources. Second one is habitat degradation. Third one is pollution. Fourth one is climate change. So over exploitation is that trying to exploit the resources, the living resources like the fish. So we get about 3.6 million tons of fish every year. By we, I mean India, from the marine side. So this 3.6 million tons is coming at a great cost because not only the economic, physical cost, but also we have to consider the reproductive capacity of the fish, the growth capacity of the fish. We have to fish at the rate which is far below the reproductive capacity of the fish, below the growth capacity, because it's a wild hunting, it's not agriculture type of domestic harvesting. So we have to think, so our estimate says that we have 2 times more number of fish boats that are required. In India, we have got about 200,000 boats, 2 lakh boats, but 1 lakh boats are sufficient to get the same amount of 3.6 million tons. So we are over-capitalized. This is happening because there is a huge fisherman population who are going out for fishing. It is their livelihood. So reducing the number of fishes is a big challenge because it involves the livelihood of a large number of fishermen. There are about 1 million marine fishermen alone, and there are another 1 million ancillary industries like fish processing, net mending, fishing harbor, etc., etc. So this is a big challenge. And what we have found is that about 1/3 of fish population, or we call fish stocks, are fished at biologically unsustainable level. So if the fishing continues at this level, then there is every possibility that the fish catch will start coming down. Now, in the last 7 or 8 years, the fish catch is not increasing from the marine side. It is stagnant. So if it continues year after year, there is every possibility that the fish population will reduce. This is as well as an example for over-exploitation from the fisheries side. Then there is habitat degradation. As I have shown you, the critical habitats like the corals, the mangroves, seagrass beds. So we find that there is a loss of mangrove areas by nearly 1% every year. The mangroves are removed for different reasons, like could be for agriculture, could be for construction purpose. So ministry is very strong against removal of mangroves, but this is happening, and there is a need to put some stop to this. Similarly, the coral reefs are also declining. So coral reefs are also declining by nearly 1% every year. Coral reefs, I would like to mention specially because they are very special organisms. Coral reefs are very, very delicate, very sensitive. They are called polyps. So they construct calcareous exoskeleton, and they like building material. They construct like building. So they construct in the sea. And they are very delicate organisms. They live inside. You can imagine roughly a termite constructing a mud tunnel, and they live inside. They're very delicate organisms. So if you take in India, coral reefs are found in many places, but more in Gulf of Mannar and Park Bay in Tamil Nadu, Andaman and Nicobar Islands, Lakshadweep Islands, and Gulf of Kutch in Gujarat. In fact, the entire Lakshadweep Island is actually sitting on coral reefs. So you can imagine the importance of the coral reefs. They are called coral islands. Many global islands are called coral islands because these small, delicate organisms they have constructed in Great Barrier Reef in Australia, 2,000 kilometer length of these mounds, 2,000 kilometers. So they are very delicate organisms. They are very, very sensitive to temperature. So warming of sea, the first organisms that will be affected will be the corals. They give support to thousands of marine organisms. I said they are actually the sort of a rocks in the sea. So the marine organisms go and take shelter in these rocks, in the crevices of the rocks. They breed, they multiply, they find food there. So they need not go anything outside. Very isolated ecosystem in themselves. So they support thousands of species, right from sea snakes to fishes to shrimps, very small worms, etc., etc. So 1 square kilometer of coral reef, if they are destroyed, you are going to destroy a few thousand species of marine organisms. So it's a very serious matter. But our main concern is that the coral reefs are subjected to intense pressure from seawater warming. 1 degree rise in seawater temperature is going to have over and above the maximum temperature. The coral polyps are going to have what is called bleaching. If you are a diver, if you dive inside, they are actually much more beautiful than our forest in the land. All types of colored organisms there. You have got flowers in the land, have to put their head in shame if you see the color of the coral polyps and the coral reefs. They're so beautiful. But there's a rise in temperature by 1 degree, they get bleached. They become pale in color because they have an organism called zooxanthellae, which give color to, they form symbiotic relationship with the corals. So once they are expelled out because of high temperature, they lose the color. They lose the nutrition derived from the algae. So after 30 days, they die off. So that is the danger of seawater warming. So going to the other issue is that pollution. Now, when you talk about pollution, we have high nutrient load entering from the river to the coastal areas. So what we find is that this nutrient load comes through the river, either sewage pollution, drainage from our households, or the large bulk comes from the agriculture. See, agricultural fertilizers, excess fertilizer, it is washed by the water, enters the river, and the river runoff, when it enters the coastal water, then there is excess nutrients entering the coastal water that causes bloom of certain phytoplankton, and the phytoplankton bloom causes it absorbs more of oxygen and also the carbon dioxide, and it changes the color of the sea. Oxygen concentration is reduced. This process is called eutrophication, and oxygen comes to zero in the coastal waters, and fishes die. So this is one type of pollution. You have the microplastics as well as the macroplastics. A rough estimate says that 20,000 to 93,000 counts of microplastics is there in 1 square kilometer of the coastal area in the sea. And similarly, macroplastics also. So this is causing a lot of problem to the marine organisms. The fourth one is the climate change. Climate change, we find that the annual increase in the sea surface temperature is about 1 degree centigrade in Indian seas. And sea level is also increasing. So in another 50 years, It's going to increase by about 0.5 meters in India. You might have seen in newspaper that major cities in the coastal area, almost every city in the coastal areas, is going to be very severely affected by the end of this century. In fact, some of the building developers here in Chennai, they asked me, sir, will they, because people are now asking when they come for purchasing apartments, you are constructing apartments very close to the coast, maybe 3 kilometers. So how long this will last? People are talking about sea level rise. So that sort of awareness has come now. Should we buy land in Chennai? The storms, there are, I think, about 20 cyclonic storms in the last 5 years. And some of them are severe, some of them are extremely severe. So the prediction says that the number of cyclones with wind speed of 100 kilometers per hour and above, that is going to increase in the years to come. So the intensity of the cyclone is going to increase. That is not the total number of cyclones. So when the intensity increases, there is going to be more catastrophe, going to be more fatalities. There's going to be intense rainfall within a specific period in a specific area. So this is what we are more worried about climate change. So there are many other things, but these 2 or 3, like sea level rise, increasing warming, and the cyclonic storms, and also specifically to marine organisms, the acidification, which is all the more dangerous for. So these are, I would say, the 4 major things that will have negative impact on the human lives, human properties, as well as on the marine organisms and the ecosystems, naturally. And when you come to the marine plastics, the pollution, I would just like to highlight plastic as well as the climate change aspect. There is an estimate that 300 million tons of plastic is produced globally every year for different purposes, the purpose of plastic. And it is also estimated that of the 300 million tons, 8 million tons of plastic end up in the oceans every year, global oceans every year. Disturbing thing is that the marine species ingest or they are entangled in plastic debris. The fishing nets are manufactured from synthetic fibers. So when they are cut, when they are damaged, fishermen cut it and leave it in the sea. The fishes get entangled and they die there itself. And there are nanoparticles and also microparticles of plastics, which are ingested by the fish. These nanoparticles, what we have found is that they come mainly from fabrics thrown out in the beach, which ultimately reaches the sea. So these are fabrics with the nanoparticles with very small length. And the disturbing thing is when the fish eat, it gets absorbed in their body tissues and we eat the fish. So we thought that marine fishes are very safe without any contamination, but the marine fishes also appear to be no longer safe because of this. This is emerging as an issue very recently. So are we also eating the nanoparticles of plastics through fish? So these are some of the issues. So what to do for this? Is it possible to have a zero wastage? May not be possible immediately. There are many things that is talked about, that is reduce the use of plastic and encourage cycling use of plastic and have some incentive to stop wastage and throwing in the beaches, in the rivers, in the water bodies, and also have a specific manufacturing novelty in producing the plastics. There are some options to mitigate the effects of plastics. One thing is that there are 3 R, the alphabet R, which is popularly told reuse, recycle, and regulate disposal. In fact, the governments, with great enthusiasm, they brought this zero wastage plastic, you should not use plastics, etc. 2 years ago, but everybody started gradually using it. And now, again, there has to be some monitoring, etc. So I think people's cooperation is very, very important. And so as an individual, each and every individual has the responsibility. There's no point in simply accusing the government. Now, coming to climate change, very brief about the climate change. That is, I think people confuse climate change with weather and also climate variability. Nowadays, there is a recent trend which says everything you do to accuse everything on climate change. But actually, it is not. See, there is a difference between weather and climate. Weather is what we see just outside our window. What is there now? It is, suppose you say it is raining now. It's a rainy day today. It stops with that. Tomorrow it may be hot. It may be warm tomorrow. That is, day to day are very short-term events is called the weather. Whereas the climate is a long-term event. If you say that Chennai is a hot place, that means the climate is hot. It is so what you are trying to say is you are trying to take an average of so many, maybe 100 years average, and say that it's a very hot place. So climate is a long-term phenomenon. Weather is a very short-term phenomenon. So for knowing the climate, you need long-term data on a particular, it can be rainfall, can be temperature, can be cyclone, whatever it is. Then there is another thing called climate variability. Climate variability normally refers to annual variability. For example, this year, this city may receive 100 centimeters of rain. Here it may be only 40. The third year it may be again 100 centimeters. There is an annual variability. There are so many reasons for that. Oceanographic reasons, atmospheric reasons, El Nino, La Nina, so many factors are there. So there is a climate variability. But when you talk about climate change, it is long-term change in the climate. If the temperature, atmospheric temperature increases gradually every year, let us say by a fraction of a centigrade, and in a period of 30 years, if the temperature has increased by, let us say, 0.5 degrees centigrade, then we call it climate change. If the rainfall has increased over the 30, 40-year period, 100-year period, gradually, then we call it climate change. The Intergovernmental Panel on Climate Change, IPCC, is also a UN organization. It considers a minimum 30 years period for changing trend in climatic parameters as climate change. You should have minimum 30 years. If you have 40 years, 50 years, it is well and good. So that is actually what we call as the climate change. Now, what causes climate change? It is basically the absorption of heat in the atmosphere. When the sunlight enters the atmosphere and when it reaches the surface of the earth, the radiation heat is absorbed by the atmosphere of the earth. And it is trapped by the greenhouse gases. And the greenhouse gases trap the heat and they give warmth to the earth. So a part of it is retained by the greenhouse gases, depending on the volume of the greenhouse gases. The remaining enters back into this outer space. But now what is happening is that the greenhouse gas volume is increasing in the atmosphere. This is because we are emitting more and more greenhouse gases, human activity. We have industries emitting carbon dioxide. So many, even agriculture emits carbon dioxide, methane particularly, methane. Our dairy emits. So there are thermal power plants emit carbon dioxide. So the carbon dioxide and the greenhouse gases concentration increases in the atmosphere. And that means that more and more of heat is trapped in the atmosphere. That is how in the surface of the earth, the temperature increases. And that is the basic science of climate change. They have got different types of greenhouse gases. More than 20 types of greenhouse gases are there, but carbon dioxide by volume is the largest. The other thing, important greenhouse gases are methane, nitrous oxide, and carbon monoxide. There are many, many other things. So if you take the example of carbon dioxide, which is by and large, in terms of volumes, very high in the atmosphere. One thing I would also like to mention here is that without greenhouse gas presence, we cannot survive in this year. They're actually good because they give warmth. If the greenhouse gas is not there in the air, the Earth's average temperature would have been minus 19 degrees centigrade, average temperature. But because of greenhouse gas, the average temperature of the Earth is now 14 degrees centigrade. Average temperature, I mean. So it gives 33 degrees centigrade heat without any cost it is giving us. So that is how we are able to survive. Now, the problem is because the greenhouse gas is increasing in the atmosphere, and the green carbon dioxide emission in the atmosphere increased from 275 parts per million in the year 1750 to 400 parts per million in the year 2020. About, let us say, about 40% or something like that. It may reach 450 ppm in another 20 years. And if the emission reaches 550 ppm, it will be irreversible if it reaches 550, which is likely to happen by the end of the century, if you do it in business as usual scenario. So this is the reason, increase in GHG emission and increase in temperature, what we call global warming. Because of that, we see every week climatic events like floods, droughts, cyclones, increased temperature, etc. Temperature for formation of low pressure area in the atmosphere, and also, depression forming in the Bay of Bengal, etc., etc. It needs particular temperature. So if the temperature, if there is an increase in temperature, the density of air gets changed. So that is why there is a rush of wind towards particular area. So temperature is a driver for many consequent events in the climate. For low pressure formation, you need a particular temperature, but it differs from one latitude to the other. We cannot say precisely what is the temperature required. It differs from one latitude to the other. So these are all interlinked. That's what I would like to say. And similarly, because of temperature, and there is a thermal expansion of water in the sea. And that is why the sea level is rising.